Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 9 video from the chapter of probability, where I will solve 3 multiple choice questions based on the supporting concept number 1 and number 2 that I discussed in part 7 and 8. So this this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it, and if you want to further share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 9 video, where I will be solving 3 multiple choice questions based on the concepts discussed in part 7 and 8. I think I forgot to write the questions. These are not the questions. I'm so sorry. Let me check. This is okay. Okay, this one is fine. Find the port. Okay, and okay, let's do this one. Okay, so in part number 7 I discussed about the concept how to find the number of integers between two given integers a and m and n, which are divisible by certain integer. And in part 8 I discussed about how to find the number of perfect squares between two given integers m and n, where obviously n is greater than m. So I don't know whether in this I have questions based on these concepts. If not, then I'm really very sorry. I will solve problems based on the concepts of part 7 and 8 in the next video. Let's but anyway, this is showing part 11. Where is part 9? Part 9 is I'm very sorry. These questions for part 9 are really not related to concepts I discussed in part 7 and 8. Anyway, I will solve these questions and in the next video I will try to solve problems based on concepts I discussed on in part 7 and 8. Okay, so these questions are from the very short answer questions from the textbook of author R.D. Sharma. This is exercise 25.1. So question number 5 says a bag contains 5 white balls and some red balls. If the probability of drawing a white ball from the bag is 2 by 5, find the number of red balls in the bag. Okay, so obviously we don't know. Now there are white balls and some red balls. So let's say the way you solve this kind of problem is that let there are, let's say, x red balls. Okay, now if you want to visualize this problem as a frequency table, you will have something like this. We have outcome and we have frequency. Now what is the experiment? You take a bag you take a ball from the bag, and it will be either white or a red ball. So that is the experiment. Now the bag contains 4 white balls. So white, I'm considering white as, by W I mean number of white balls. So its frequency is given to be 4, and I am considering capital R to be red balls, and its frequency we don't know. So we are considering x to be the number of red balls in the bag. The problem has asked to find the number of red balls in the bag, where it is given that the probability of drawing a white ball from the bag is 2 by 5. Now what does it mean by the probability of drawing a white ball from the bag? It means that if you randomly select a ball from the bag, what is the chance that it will be a white ball? Basically it will be based on the empirical formula. So the probability of white, PW, means the probability that it is the probability of selecting a white ball from the bag. So it will be based on empirical formula, which is small m by n, where n in this case is the number of balls in the bag and small m is the number of white balls in the bag. So this is equal to, m is given to be 4, and what will be small n? There are 4 white balls and we have considered x to be number of red balls. So total number of balls in the bag is 4 plus x. This is given to be 2 by 5. So clearly we see we get a linear equation in x, and we can easily solve for x. So doing cross multiplication, I have 20 is equal to 2 multiplied by 4 plus x. This implies if I divide both sides by 2, I get 10 is equal to 4 plus x. This implies x is equal to 4 minus 10 minus 4, which is 6. So x, the value of, there are 6 red balls in the bag. Let's see the next problem. Well, if I am doing any kind of calculation mistake, or if I am solving the problem incorrectly or applying concepts incorrectly or incorrect concepts, then please feel free to let me know in the comment section. I will highly appreciate that, because I am not really bothered whether my answers are coming correct or not, but I hope that I am applying the concept correctly. Next problem, question number 6. A die is thrown 1000 times. If the probability of getting an even number is 2 by 5, how many times an odd number is obtained? So if I throw a dice, if I throw a die 1000 times, I know that every time, in every trial, I will get a number which is which will be either one number from 1 to 6, and of all these numbers 1 to 6, any number is either even or odd. So I can the result of the experiment, which is throwing a die 1000 times, where here n, that is the number of trials, is 1000, and a single trial is you throw a die, it could be any number from 1 to 6, that is a single that is a trial. So let's say if I can tabulate the results of this experiment as usually you are given the frequency of the numbers 1 to 6, but I can also give the results of this experiment as the frequency of even numbers and odd numbers. So let's say E means number of times out of these 1000 times. Let's say the E means in a single throw an even number, the die showed up an even number, and O means in a single throw, that is in a single trial, the die was showing up an odd number. Okay, so if the if the probability of getting an even number is 2 by 5, how many times an odd number was obtained? Okay, let's say our die is shown. Okay, how many times an odd number is obtained? Okay, we have to do it from the very basics. Okay, so let's say the number of times an even number, the die, an even number was obtained when a die was thrown out of the 1000 times. Let's say that be x. Obviously the remaining 1000 minus x, times the die was showing up an odd number. Okay, so now what is the probability that in a single throw the die was showing up an even number, which is probability of E based on the empirical formula small m by small n. It will be x by 1000 minus x, and this is given to be 2 by 5. Okay, so from here we can see we are getting a linear equation in x, and we can easily solve for x, which will give the number of times out of the 1000 times, the number of times the die was showing up an even number. So let's solve for x. Doing cross multiplication, I have 5x is equal to 2 into 1000 minus x. This implies, simplifying the right hand side, I have 5x is equal to 2000 minus twice x. Bringing all the x terms to the left hand side, I get 3x is equal to 2000. This implies why x is not, x has to be an integer. 2000 divided by 3 is not an integer. Am I doing it correctly? A die is thrown 1000 times. If the probability of getting an even number, is is 2 by 5, how many times an odd number is obtained? Okay, so I have considered the number of times an even number was obtained is x. Then obviously the number of times odd number was obtained should be 1000 minus x, and so the probability of even number should be x by 1000. Oh, I'm sorry. Why 1000 minus x? Small n is 1000. Small n is 1000. Okay. So so we have this. Now clearly, if I solve for x, this will imply x is equal to 2 by 5 multiplied by 1000, which will be 400. So clearly, then the number of times odd number was obtained is, we can say that number of times odd number was obtained is equal to 1000 minus x, which is 1000 minus 400, which is 600. So 600 times an odd number was obtained. Okay, let's see the next problem. Question number 7. 3 coins are tossed at the same time 200 times with the following frequencies of different outcomes. So we are having outcomes 3 heads, 2 heads, 1 heads, and no heads. So as you can see, all these events, let's name these events that let's say I am naming the event E1 to be 3 heads. That is, if I toss 3 coins at the same time, 3 heads will show up. That is what I am naming the event to be. That event to be E1. Similarly, let E2 be the event 2 heads. That is, 2 heads will show up when I will toss 3 coins at the same time. Similarly, E3 be 3 heads. Sorry, E3 be 1 head, and let's say E4 be 0 head. Quite obviously, if you toss 3 coin, obviously these 4 are the possible outcomes. Either it will be 0 head, or it can have 1 head, or it can have 2 head, or it can have all 3 heads. So E1 E1, E2, E3, E4, this is just for the sake of discussion, are elementary events of the experiment. Elementary events of the experiments, which means that the probability of even some of the probabilities of these events will be equal to 1. Okay, now what the question has asked, find the probability of getting at most 2 heads and at least 2 heads. These events, at most 2 heads and at least 2 heads, they are compound events which we have to define as a collection of these primary events E1, E2, E3, E4. Now before that, let's quickly find the probability of all these elementary events. So probability of E1 will be, now what is this event E1? If I toss 3 coins at the same time, then all the coins will show up heads. That is, I will get 3 heads. That is the event E1. So what will be its probability? Based on the empirical formula and the data given, it will be 23 divided by 200, which is approximately 0.115. Okay, and what is the probability of E2? That is, if I toss 3 coins at the same time, what is the probability that there will be 2 heads and one tail? It will be 72 divided by 200, which is equal to 0.36. Okay, and what is the probability of E3? It will be 77 divided by 200, which will be 37. It will be 0.375. And what is probability E4? Probability of E4 will be 28 divided by 200, which is 0.14. Now if you add all these probabilities, 0.115, 0.36, 0.375 and 0.14, they should all add up to 1. I will quickly check if that is correct or not. 0.36 plus 0.375 plus 0.14. Oh, it is coming out to be 0.99. Why is it so? Why 0.99? I think I have done some mistake. 28 is 14. Okay, 77 is, how much is 77 divided by 2? 38.5. Oh, sorry, this is not 0.375, but this is 0.385. Now it will be correct. Okay, so we have this. Now the question has asked to find the probability of getting at most 2 heads. Let's say this event, that if you toss 3 coins at the same time, there will be at most 2 heads, means there will be either 2 heads, it can be 2 heads, at most 2 heads means it can be 2 heads, it can be 1 heads, or it can be 0 heads. So I'm calling that event to be P, and this event I'm calling to be Q, at least 2 heads. At least 2 heads means it can have, if I toss 3 coins, then either what is the probability? Then the event is that it can have 2 heads or 3 heads. So I have to understand how these compound events P and Q, the compound events P and Q will be definitely defined as the collection of the elementary events E1, E2, E3, E4. So what will be, which elementary events will belong to the collection of the compound event P? So at most 2 head means it can have 0 heads, which means event E4. It can have 1 head, which means event E3. and it can have two heads, which means event E2. So the collection of the elementary events E2, E3, E4 is defining the compound event P. And similarly, for the compound event E, what are which elementary events is making up, or so the compound event Q will also be a collection of elementary events. So what are those elementary events? So at least two head means it can have two heads, which is E2, or it can have three heads. Since there are three coins, it cannot have more than three heads. So E2 and E3. Okay. So we have to find the probability of P and Q. So probability of P, probability of a compound event is always equal to the sum of the probability of the elementary events which are present in its collection. So probability of P will be probability of E4 plus probability of E3 plus probability of E2, which is probability of E4 is 0.14 plus probability of E3 is 0.385 plus probability of E2, which is 0.36. Let me quickly get the results using my calculator. 0.385 plus 0.36, it is coming out to be 0.885. So this is the probability that of having, when I toss three coins at the same time, I will get at most two heads. Its probability is 0.885. Similarly, now probability of Q, the compound event Q, which is at least two heads, will be probability of the elementary event E2 plus probability of the elementary event E3. E2 is probability of E2 is 0.36 and probability of E3 is 0.385. How much is this? Okay, 0.36 plus 0.385 is equal to 0.745. When you do this kind of problems, always check, always be careful that none of your probability values are coming greater than 1. Any probability value should always be greater than equal to 0 and less than equal to 1. Okay. So let's see if this. Okay, so there are no other problems. I hope solving these problems will help you understand how to apply the concept of elementary events, compound events, and solve and the concept of finding the probability based on empirical formula. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve a few problems based on the concepts discussed in part 7 and 8, which was how to find the number of integers lying between two given integers which are divisible by some given integer, and how many perfect squares are there between any two given integers. So please stay tuned for the next video. It will come soon. I am ending the video here. Thanks for watching, and until the next video, take care and bye.